Okay, what's up mga kadiri? Welcome to FS257's last lecture for the SEM. And today we'll be discussing advances in dairy processing. There will also be some a reading on functional dairy products in your study guide. So since this topic is also part of your reporting, I will be covering those processes that will not be covered in the oral report of your classmates. Alright, so okay, to begin with, we do have these emerging technologies that I'll be discussing. Hindi naman to all-inclusive, no? But then, ito yung medyo mga trending na. So, we'll look at some of them, both for thermal and non-thermal processes. Okay, so we have ohmic heating, microwave heating, and radio frequency heating, as well as UVC and CO2 processing. So again, first we have ohmic heating, or what we also call as direct resistance heating, or volumetric. It's a type of volumetric heat generation, which means yung heat ay hindi nanggagaling dun sa labas or an outside source, but rather nag-generate mismo doon sa loob ng food product, and therefore parang mas uniform siya kasi hindi siya yung parang conduction muna galing sa outside source and then convection sa loob. So, essentially, when you have ohmic heating, di ba kapag meron kang electrical circuit, tapos, well, yung food now becomes a part of your electrical circuit. It now becomes a conductor, dumadaloy doon yung kuryente, and in the process ng pagdaloy ng kuryente sa food mo, ay umiinit siya. So essentially, you could think of yun nga, you have an electrical circuit, cut off a piece of wire and replace that piece of wire with your food, and then that's it, no? So this could be as easy as, having a battery, two pieces of wire, and dipping them in food. But of course, in reality, it's more complicated than that because you have to put other sorts of electronics to regulate the amount of current flow, to control the temperature and rate of heating, and so on and so forth. Okay. So again, when you apply electric potential across food, there is a flow of current through the three-dimensional food network. One of the advantages or many of the advantages include the uniformity of heating, kasi hindi ka nagre-rely doon sa conduction from the outside and then convection sa loob. That also means mas mabilis yung processing time niya, kasi di ba parang pag nagluluto ka ng itlog, maantayin mong mag-penetrate yung heat dun sa pinaka-center dito. Pretty much simultaneous yung heating ng buong food matrix mo. And there's a very high energy efficiency, no? Yung mga heat loss mo, kasi yung maliit dahil yung kuryente yung ginagamit mo converts into heat at a very high rate. And then less yung fouling dun sa surfaces, kasi actually ang pinaka-surface lang talaga na in contact with the food other than the container is yung pinagdadaluyan ng electric current mo, no? And okay din siya for viscous foods, as you would know. Kapag mas viscous yung pagkain, less yung effect ng convection sa kanya, mas mahirap o mag-circulate yung heat. Pero dahil dito, hindi naman masyadong convection yung manner of heating niya, then mas mabilis siya. And in the case of dairy products, there is a better sensory quality dahil nga mas uniform yung heat treatment. Walang portion na na-overheat masyado compared to the rest in the process of trying to make it let's say at least pasteurize yung level niya. And they also found out that if you control the process of ohmic heating, you can fine-tune the protein structures, yung na-alter siya in the process, kasi as you know, di ba, nagde-denature yung proteins in milk at roughly around 60 degrees Celsius, no? So kung ma-fine-tune mo yung temperature control nun, pwede mong i-modify yung protein characteristics ng milk mo. Alright, on the other hand, since meron kang electrodes kung saan yun yung in contact with the food, kahit na maliit na part yun, ay pwedeng magkaroon ng electrolysis, and when that happens, you can form harmful chemical compounds. There is a solution though, which is yung treat or pag-coat ng mga electrodes mo. Now, in terms of applications, marami na naman din silang na-experiment, including cow and buffalo milk, dulce de leche infant formula, and flavored whey beverages and sweet whey. So, mostly for liquids naman ito ina-apply, no? Kasi mas mahirap mag-conduct through, let's say, powdered solid ng kuryente, right? Okay, next naman is microwave heating. You're already probably somewhat familiar with this dahil karamihan sa atin ay may microwave sa bahay o di kaya nakakita na sa 7-Eleven or sa lab, sa school. Right? So, it's also a form of volumetric heating in a way kasi more or less kaya niyang simultaneously i-heat yung labas at loob. Although there is a concept of microwave penetration, which means manggagaling pa rin sa labas yung microwave, pero hindi siya through conduction lang, like much in the same way that light can penetrate through an object, diba? So parang ganun siya. We use a specific range of electromagnetic waves for microwaves, 300 megahertz to 300 gigahertz. And what it does is penetrates the samples and causes molecular vibrations, especially targeting yung ating polar molecules, which ang most abundant is water. So, ang microwave mas effective siya sa pangabagay na maraming tubig. Sir, bakit ganun? Pag nagma-microwave ako, pati yung taba umiinit. Well, most likely umiinit sila dahil kahit paano in contact sila with moisture in your food. Okay, and kapag nag-vibrate na yung water molecules mo, of course, they can now transfer the energy to conduction or convection. Okay. When microwaving food, especially for yung mga applications natin dito, which is for industrial, important yung dielectric properties niya. Okay. And I have a video on this food physics, which I'll put the link na rin lang sa ating course guide optionally if you want to understand more on that, kasi mas in-depth na discussion yun. Okay. And in the case of dairy products, essentially ang ibig sabihin nito ay nakadepende sa food composition, proximate composition ng dairy product mo kung gaano ka-effective yung microwave heating sa kanya. Okay, one of the main advantages is a non-contact heating method. So you can actually package the food muna bago siya i-heat. And less yung routes ng contamination mo kasi wala nang direct contact. Doon lang siguro sa surface kung let's say pipes yan na dinadaanan ng gatas or what. And then it's highly energy efficient as well compared to traditional methods, and there is less fouling kasi nga wala namang direct contact. Although fouling can still occur medyo kung hindi maganda yung settings mo, much in the same way na pwede pa rin mag-reach ng higher temperatures yung food mo depende sa composition niya. So, other disadvantages noted from some studies is the possibility of off-white discoloration, and there's a possibility of non-uniform heating in emulsions and in certain foods. No, kahit sa bahay naman, di ba mapapansin mo minsan pag nag-microwave ka, may portion na mainit, may portion na malamig pa. So, this is especially troublesome if you have closer to solid foods or viscous foods, no? Pero kung halimbawa medyo malabnaw-labnaw lang na mga closer to tubig yung consistency, then there shouldn't be much of a problem. In terms of applications, they've looked at model systems and tried it for raw and concentrated skim milk, Lord cheese, which is I think something not available in the Philippines, fresh cheese, and white and chocolate drink. So essentially, mas okay siya doon sa kung hindi man liquid dairy products, yung mga cheeses na hindi yung blocks, no, yung maliliit lang like parang grated or mas maliliit yung particle sizes. Okay. Alright, so we also have radio frequency and hot air assisted radio frequency heating. So, like microwaves, these belong to the electromagnetic spectrum. So again, you can refer to the food physics lecture since may basic discussion din doon on PM. As you know, radio frequency, obviously, ito yung ginagamit sa mga radio stations natin. So, they have the characteristic of having longer wavelength, meaning mas okay yung penetration nila, no? Kasi ang electromagnetic waves are always a combination of frequency and wavelength, right? So, unlike microwaves, ang mas microwaves targeting polar molecules, ito naman, dissolved ions yung mas malaking determinant ng kung gaano siya ka-effective in foods. Granted, it hasn't been studied much for commercial use, but some studies tried it even for drying of powders, no? Of course, with the combination of hot air convection. Parang mas pinatindi lang nung radio waves yung hot air convection process. Okay? Advantages include heating independent of product thermal conductivity. So, it's a physical property that we often consider, no, when trying to heat a product. But since radio waves do not function primarily through heat conduction, but rather through the penetration of the radio waves and transmitting energy directly to the molecules, then mas okay ito dahil mas kaya mong control ito, na. And then there's very high energy efficiency as well as low space requirements for the equipment. On the other hand, wala pa siyang commercial operations, and we have seen this being used in both powders and liquids, milk or dairy products. Alright, so moving on to our non-thermal methods. First, we have ultraviolet C. So this has been extensively studied in a lot of different products, especially by our very own microbiology lab here in SHE, yung Food Microbiology and Hygiene Laboratory. And there are also some attempts to apply these to dairy products. So again, although this is also in the spectrum ng electromagnetic radiation, yung method of action niya does not really rely on heat generation to inactivate microorganisms, no? Kaya under non-thermal siya, unlike yung mga nauna natin na microwave and radio frequency. So what UVC does is, first of all, it uses 200 to 289 nanometer na wavelength ng ultraviolet light from UV lamps, which are either mercury, LEDs, or xenon or microwave xenon. And what this electromagnetic radiation does is to disrupt the cell DNA and RNA structures, preventing cell growth and replication. So, hindi siya pumapatay through temperature and inactivation of proteins, but rather through directly attacking the cells. Okay? So, dahil dito, mas hindi na-alter yung sensory properties niya. No? Yung mga changes na usually attributed to heat treatments ay hindi masyadong mararamdaman kapag UVC ang ginamit mo. Okay. On the other hand, one caveat of course is highly dependent yung treatment efficacy mo sa composition ng product and optical properties niya, since as we know, kapag mas maliit yung wavelength, mas mahina yung level of penetration to the extent na essentially for opaque liquids, parang halos surface sterilization na lang yung kinalalabasan niya. Hindi talaga siya tumatagal. So, it's very tricky to use this in dairy products. Alam naman natin, ang milk ay mostly opaque, no? Kasi talagang either you have to siguro pass it through a very thin tube, parang capillary tube, or kahit i-increase mo actually yung parang inactivation time niya, baka hindi rin masyado mag-penetrate pa rin. So, on the other hand, ito naman ay nagamit na sa human milk, bovine milk, and raw goat milk. The study on human milk is actually done by the late Dr. Gabriel and one of our former students, Miss Marquez. Okay, lastly, we have CO2 and supercritical CO2. Carbon dioxide is a naturally occurring fraction or component of milk, although yung natural occurrence na is mababa na concentration. So you can artificially increase the amount of carbon dioxide through carbonation, much in the same way that we do with soft drinks. Siyempre, ang labas nito parang magkakaroon ka ng milk na soft drinks. Of course, if you tasted some, there are available in the market. Locally, yung Milkis, you found it. And as we know, when carbon dioxide is dissolved in an aqueous solution, it turns into carbonic acid and thus lowers the pH and adds that typical texture ng soft drinks pag nilunok mo may hagod sa lalamunan. On the other hand, when you use supercritical CO2, so it's similar to the discussion on high pressure processing, except that CO2 yung gamit mo. Marami siyang positive effects like retarding microbial growth and enzyme inactivation, therefore leading to shelf life extension without much effect on the sensory quality. On the other hand, merong regulatory gaps ito kasi even though supercritical CO2 is a process, parang sa technicalities like sa US FDA yata, naka-count siya as an ingredient, and therefore if you have, let's say, raw milk, ginamitan mo ng supercritical CO2 na process, hindi mo na siya pwedeng i-label as simply milk, no? Kasi parang ang lalabas ng kinarbonate mo siya, even if the end product is not like carbonated beverages per se, right? And in terms of applications, marami na ring naaral whether as inclusion of CO2 or using supercritical CO2 processing. You got anywhere from ice cream to cottage cheese and yogurt. Yun nga, yung mga nabibili natin flavored dairy beverage, sometimes carbonated, and so on. No? So, ang dami talaga ang applications for this one. Although, yun nga, regulatory standards, hindi pa rin basta-basta masabi na non-carbonated drink or item yung labas ng mga pinagamitan yan because of parang may gap sa batas, especially in the US. Philippines, maluwag actually yung ating mga laws unless yun nga may standards tayo. Okay, so our short lecture ends here. Medyo introductory lang talaga siya. Hindi ko na pinili to go deep into each one, no? Lalo na baka na-overload na rin kayo for this sem. So, hindi ko na rin kayo bibigyan ng additional forum activity for this module. But I think it would be up to you kung meron kayong natipuhan basahin. The references are all there. And most of these can be accessed naman, especially using your UP mail address login for Science Direct and the like, Elsevier, etc. So, yun lang and have a nice day.